Hello, Professor and class. My name is Issa Yusuf, and this presentation walks through my penetration testing lab using Metasploitable 2 as a target and Kali Linux as the attacker. I would cover how I planned and executed the penetration testing, the tools and scans I used, and how I performed a risk assessment and gap analysis, and the hardening steps applied on Metasploitable 2. I'll close with why I chose certain mitigations, which vulnerabilities were impacted, and some lessons learned from hardening the system. From planning, I treated this as a focused single target engagement. The goal was to understand how an external attacker on the same network would view Metasploitable 2 and identify vulnerabilities that could be exploited. The scope was limited to one Metasploitable 2 VM as the target and one Kali VM as the attacker. I did not scan or attack any other machines or network. As I followed lab constraints, no real production system were touched. I only collected enough proof of concept to validate vulnerabilities and avoid any destructive activities. This kept the work ethically controlled and fully aligned with our cost rules itself. My penetration tests followed a simplified version of a standard methodology. First, I did a recon and enumeration. I confirmed the target IP, then I used Nmap to discover open port services and then versions. Secondly, the vulnerability scanning. I used tools like Nikto, OWASP, and Nexus to identify potential vulnerabilities in web services and the underlying OS. Thirdly, the validation and analysis. I reviewed the result, removed obvious false positive, and focused on high impact vulnerabilities like remote code execution, weak authentication, and outdated services. Finally, reporting and remediation planning. I translated those findings into a risk assessment, proposed countermeasures, and then selected specific hardening steps to implement locally on Metasploitable 2 as part of Part D. First of all, I would like to go into how important penetration testing is and what the value of penetration testing and hardening procedure means for us. Penetration testing is valuable because it shows how systems behave under realistic attack conditions. Not just on paper, it helps organizations to discover real-world attack paths an attacker could use, to validate whether existing security controls are actually effective, prioritize fixes based on risk instead of guessing. On the procedural side, things do not always go perfectly. If I realize I have deviated from agreed process or scope, the first step is to stop, document what happened, and notify the appropriate owner or instructor. Then I would realign with the rules of engagement and update the procedure so the same mistake is not repeated. Treating failures as learning points rather than hiding them in key professional penetration testing is the key to professional penetration testing. For Part B, I use a very standard lab setup. Kali Linux served as the attacker with all the offensive tools installed by default. Metasploitable 2 was the target using known credentials. MFadmin for local login later in this assignment. Both VMs are placed on an isolated host only or internal network segment, so no traffic left the lab environment. The main tools were Nmap for network scanning, Nikto and OWASP for web application assessment, and Nessus results for topic. And Nessus results from our topic 5 vulnerability scanning. Nmap was the first step to understand the attack surface. I scanned the Metasploitable 2 IP, found multiple open ports, including SSH, HTTPS, HTTP, and in the domain itself. The version detected flagged in Nmap also helped identify outdated service versions, which is a big red flag in any environment itself. The scan gave me baseline of where to focus. Nikto is a simple but powerful web scanner that checks for common misconfiguration and known issues. Against the Metasploit 2 web server, Nikto flagged an outdated Apache version, directory listing, and several default or test pages that should be exposed in a production environment. OWASP goes a bit deeper than Nikto, focusing on application level behavior. When I proxied traffic through Zap and ran an active scan against the Metasploit web application, Zap flagged potential cross-site scripting, missing security headers and other OWASP top 10 style weaknesses. In real environment, this could allow attackers to steal sessions, tokens, manipulate user input, redirect user to malicious sites, or extract backend data. For Nexus, I use a scan from Topic 5 as a foundation. Nexus organizes findings by severity, which is helpful for prioritization. In my result, I saw critical vulnerabilities tied to outdated services, high risk such as weak authentication or known remote code execution exploited, and medium risk like use of insecure protocols and missing patches. This gave a more formal risk-based view of the host and helped me decide which vulnerabilities were most important to address in my risk assessment. Using the Nmap Nikto Zap Nexus result, I performed the basic risk assessment. Asset at risk included the integrity of the Metasploit server itself and any data hosted on its service. Even in a lab environment, this simulates a production application or database server. The highest risk came from outdated servers with known exploits, default or weak credentials, and multiple web application weaknesses that could easily be chained for deeper compromise. From a gap analysis perspective, the host clearly lacks patch management, network segmentation, and any meaningful logging or monitoring. If they were a real server, an attacker could compromise it with minimal chance of detection. Based on the risk and gaps, I propose the following countermeasures. Patch and update. Bring the OS and major services up to date to known CVE are addressed. In a real environment, this would follow a change management process. Disable unnecessary services, turn off things like Telnet and any legacy FTP or demo service that are not required. Reducing the attack surface is one of the fastest ways. Strengthen the authentication process, remove default credentials, basic firewall and restrict inbound traffic so only required ports are reachable. Web server hardening, disable directory listening, remove test bases and apply secure headers. Expected results would include fewer exploitable services, visible to Nmap, reduce critical findings in Nexus, and less exposure in Nikto and Zap scans. For Part D, I logged into Metasploit 2 locally as MFadmin and implemented at least 3 of the proposed changes. I disabled Telnet, an insecure protocol that sends credentials in clear text and is not needed in modern environment. I changed the default MFadmin password to a strong unique value. Default credentials are one of the easiest ways for attackers to gain initial access. I configured basic firewall rules so that only necessary ports such as SSH and HTTP were allowed, and even those could be limited to specific source ranges in a real deployment environment. The changes I picked were chosen for 3 reasons: cost, speed, and impact. They are low cost and quick to apply, which makes them realistic even in a busy production team. At the same time, they hit high likelihood, high impact issues, insecure remote access, and default passwords. As expected, after disabling Telnet, it no longer appeared in Nmap scan, and any vulnerability findings related to Telnet were effectively removed. Changing the default password also removed one of the most obvious paths to compromise. In a full rerun of Nessus and other scans, I would expect to see fewer critical issues and a smaller exposed surface. In practical, there might still be more to work around patching and application level vulnerabilities, which we can highlight later. A few lessons that stood out for me for this lab is, first, penetration testing and scanning changes how you look at the system. Instead of just seeing a VM, you start seeing exposed ports, added services, and their potential attack path. Second, tools alone are not enough. Nessus, Nmap, Nikto, and Zap are powerful, but they only create value when findings are prioritized and turned into concrete remediation actions. Third, simply configuration changes like disabling unused services and changing default passwords can significantly reduce risk without big budget or complex projects. But finally, though, hardening is not a single event. New vulnerabilities and misconfiguration appear over time. So organizations need ongoing scanning, monitoring, and updates of the system. This lab was a good reminder that effective security is a cycle of testing, fixing, and testing again. And here's a couple of references that I use for preparation of this lab. Thank you very much for listening. My name is Issa Yusuf.